Hello. Welcome and welcome back to a new Unreal Engine video. Today's prototyping video comes from a viewer's comment. Little Demo 365 writes, "Save system cross levels, please." Thank you for the support and comment, Little Demo. I was wondering the same thing as well. So the question is today, can we create a fairly generic, multi-level supporting save system in Unreal Engine? Let's begin. Let's start here by creating a save game object along with its interface. The interface is going to have as save game, which is going to return its interface, and then it's also going to have as save game object, which is going to return the object. Implementation for both functions is just going to return self. Let's go ahead and create a new folder here for our properties. The properties here are just going to contain one variable. It's just going to be the system properties. These system properties are just going to hold a name with the amount of save slots as integers and save games. The interface is just going to have an as with the get. In our properties file now, we can simply set up how many save slots we want. Let's go ahead and create a new game instance. This is going to hold all of our data for the entire current running instance. And of course, it wouldn't be my own touch if we didn't include the interface. The interface only has the as right now. New game instance in. To save things in our level, we're just going to need a few things. We're going to take two structures. We're going to combine the savable data into the actor data, which is going to hold our actor data for our levels. We're also going to use this interface to denote which actors are going to be saved and loaded. The savable data structure is just going to have any data we want to save. It's going to have to be a map in whatever data you want to save. The actor data is going to hold the actor class, the actor transform, and the actor savable data structure. The savable interface is just going to have the as, the save savable, which is going to take in the savable data, and the load savable, which is going to output the savable data. Let's now go ahead and create a level data structure. This is just going to hold a level actors. That's going to be an array of actor data. Over in our save game interface, let's add a getter and a setter for level data map. It's just going to be a map of level datas. Over in our save game object, let's create a variable, save game data. That's going to be a map of strings and level datas. The getter is just going to be a simple getter, and the setter is just going to be a simple setter. In our game instance interface, let's just basically do the same thing as the save game, but this is going to be for quick save data. In the game instance now, let's just create that same variable, but name it quick save data. The simple setter is just going to be a simple setter. The getter is just going to be a simple getter. In our game instance interface, let's go ahead and add a new function here, add quick save data entry. It's going to take in a level name and a level data. Implementation will just be a simple add. In our game instance, let's go ahead and create three new variables, save system properties, which is going to be our system properties data asset. We'll need the active slot, and then we'll need the save game slots, which will be an integer map with our save game interfaces. In our game instance interface, let's add two new blank functions, save quick save data to slot and load slot to quick save data. Implementation for the save is fairly simple. We're just going to get the active slot, set the data as that save game object, and then we're just going to save it to the slot. On the completion, we're just going to update our map. The load here should be fairly simple as well. We're going to get the active slot, we're going to load the game from the slot as that save game, and then we're going to set our data. After setting it, we're going to just update our map. In the game instance, let's override the init function to load our properties. We'll find the save game. If it exists, we'll load that save game and set our quick save data. If it doesn't exist, we'll grab that class and we'll construct it and we'll add it to our map. In the interface for the game instance, let's do a set active slot. Implementation is just going to set the active slot. Let's go ahead and add some gameplay tags so we know what state we're saving and loading in. Let's now go ahead and add a new gameplay tag in our game instance for save state. The default is going to be the save state ready. Now when we do our saving and loading with our async, we can simply set this corresponding states, and then when it's completed, we can simply set it to ready. We can do the same thing now in the save and loading for the quick save data. Whenever we save it, we can set the state to saving. On completed, set it to ready. When we're loading, we can set it to loading, and on completed, we can set it to ready. Let's go ahead in the interface for the game instance and just add a simple getter for that value. Implementation is just a simple getter. Over in the savable interface, it looks like I accidentally put the pins backwards. The save should be on the output and the load should be on the input. In the savable interface, let's go ahead and add a blank function so we can destroy the savables. Let's now begin working on the component to control our save system. The interface here for the save system component is going to have four functions: save level, load level, quick save level, and quick load level. These are going to control our functionality for how we're going to save and load levels. In our component, we're just going to need some way of finding all the classes with the savable interface, so let's just go ahead and create a macro. We're just going to do it through a for each loop and just return all the pins. In the begin play, let's just go ahead and get the game instance and promote it to a variable. Let's start in the component by implementing the quick save level. It's just going to call a private function, do quick save level. On the do quick save, we're going to get the current level name, use that macro to loop through all of our actors, save that data, get the class, get the transform, make that actor data, and add it to a local array. Upon completion of that macro, we're going to take all that actor, make a level data along with the level name, and send it to a quick save data entry on the game instance. The regular save here is fairly easy. We'll do that quick save and then go to the game instance and save that quick save data to whatever active slot is currently active. On the quick load level, we're going to call a private function, do quick load level. This quick load level is fairly straightforward. We'll get the current level name, use that macro to loop through all the savables, destroying them. Then we'll get the quick save data, get that level data, loop through them, break that actor data, spawn the actor at that transform as that savable, and then we're just going to pass that data through. To do the load, we're just going to basically do the opposite of saving. We're just going to load that data from the slot, and then from that slot and quick save data, we're going to do that level load. To help us here, let's go ahead and create a macro library. It's just going to have one entry, make map entry. It's going to take in a string ID and a wildcard of data and output the map, and this is all it's going to be. Let's go ahead and create a savable actor implementing our savable interface. Implementation for the destroy will just simply look like this. For saving here, let's just simply get the static meshes world transform, make that map entry from the macro, and just simply send it to that savable data. In the save, we're saving it under this ID of mesh transform. In the load, we'll simply use that simple string and we'll just load it from that same data. Let's simulate physics, and this is the reason why we're saving the mesh transform, is because the mesh transform is different than the actor location when it's a physics object. In our character now, we can simply add the save system component and promote it to a variable. I'm going to go ahead and set up a few key presses for quick saving, quick loading with a print string. Looks like we're having a little bit of a problem with the macro, so I'm just going to switch this out in the save data and the savable for a simple make map. All right, let's jump in and test functionality. We see we have a line of boxes. If I go ahead and hit one of these boxes, you can see it'll fly away. Let's hit save. Now let's load it up. Oh, we can't see anything, but if I hit this one back and we load up, it comes back. If I hit this box away and I hit save and I hit load, we're there. If I go ahead and just hit these boxes away, hit load, they all come back. With a handful of messy redirects, let's test actual saving and loading now. Okay, let's jump in. Let's test functionality. I'm just going to hit a box away here. Hit this box away. I'm going to hit save. Now let's jump out. Let's end play. Let's jump back in. Hit load. Turns out the issue is with async, and all we have to do is add a simple delay and check to see if we're ready. If we're ready, we'll load the level. Now we can see when we hop in and we press 2, we load the level and that box changes. Let's go ahead and do it again. I'm just gonna pick up the ear, and I'm just gonna knock this box away. We'll hit save. I'll hop out. We'll hop out of the editor. We'll jump back in. I'll press 2, and the boxes are saved where they were. Now, it wouldn't be a save system without a saving and loading screen, so I went ahead and created two basic ones. One's a black screen, one's a plain screen with saving. That's about it. Over in our system properties, let's go ahead and update them for the widgets now. We can update it for the saving, the loading, and we'll include an autosave timer. Okay, now we can just plug in our values here for the save screen, the loading screen, and I'll set a default for 10 seconds for the autosave for now. Over on the init function of our game instance, we can now just create those widgets and set those as variables. We don't need them as interface references. We can simply use them as objects because they don't have to deal with data. Now on our rep notify function, we can just simply do a switch on the gameplay tag. If we're loading, we'll add the loading screen. If we're saving, we'll add the saving screen. And if we're in the ready state, we'll do a sequence to check to see if either one of those are in the viewport. If they are, we'll just remove them. Let's go ahead and add a 1-second delay to the end of every saving and loading so we can see that the screens are working. After a little bit of bug fixing, it was looking like I was getting a null on the initial save, so it looks like I have to do a little something slightly different with the active slot here, and I'll call that function that we have for loading the slot to active save data. And then when we construct the save here, we actually have to save it first before we can use it. Okay, but that out of the way, let's go ahead and test functionality. I've got my boxes, I've got my gun. Let's fire some boxes. Let's save. You can see in the bottom right the saving little thing that I made. And then if we hit load, there's a loading screen right there. If I whack this box away, if I load, well, the boxes pop back up. But the thought is there. You know, the thought is there. In the game instance interface, I'm just going to add a toggle loading screen. Taking in a boolean is loading. Implementation is simply going to toggle between loading and ready. Now in our component on the load level, we can just simply put the delay in the middle when we want to load it and just simply toggle the screen. Go ahead and test functionality. It might need a little tweaking, but it should be fine. I saved, load, there it is. You can see saving in the bottom right. If I hit box and I load, the box comes back. So you can see that the screens pop up. If I come out of the editor now and I hop back in, I hit the loading, you can see the boxes are now back where they saved before. If I decide to hit it this one, save it, and then I hop back out, let's go back in, I hit loading, you can see the boxes are back where they were. I'm going to go ahead and set up a few key presses so we can swap our maps. All right, let's start by testing functionality here. We're in map 2. Let's hop in. Let's shoot those two boxes at the end here so we can save that. Go to the next map, map 3. Let's shoot those two boxes at the end there. And we'll save it. Let's go back to the original map. Let's load it up. Okay, those two corner boxes are knocked off. Let's go to the next one. And those two boxes are knocked off. Very good. Now let's see if we can resave some changes. I'll whack those two boxes, save it, go to the next map. I think I'll whack like more, or let's load it up and see. We'll just take all of them actually. That should be fine. If I save that and we go back to the original map here and I load it up, you have those two boxes in the corner. If I go to the, is it this one? Oh, okay, that one's still in the corner. Then this one should be all scrambled. Okay, looks like it's working. All right, that will conclude today's video. Shout out once again to Little Demo 365 for the suggestion. I hope that's my solution answered your question. If you enjoyed this video, go ahead and give it a thumbs up. And if you have any suggestions for systems you'd like to see, leave a comment. Bye-bye for now.